Today we're going to take a look at two new rules on how to find derivatives of even larger functions, applying the rules we already know from the previous lesson. Let's go ahead and get started. So in the previous lesson, we saw how to apply the following rules to any function we have. So we learned how to apply the power rule, where we take the derivative and move the power down to a coefficient and then take away one power. Constant multiple rule, where if we have a constant times a function, all we have to do is remove that constant out and then find the derivative of a function. And then the sum and difference rule, where if we're adding a bunch of functions together or subtracting a bunch of functions, all we have to do is find the individual derivative of each function. Okay? Today, we're going to look at two new rules, the product rule and the quotient rule. So this is kind of like what we saw at the very beginning of the year with composite functions and rational functions. Now we're going to look at how to find the derivatives of a composite function or a rational function using these two rules. The derivative of a product of functions looks like this. We're going to take the derivative of the first function, multiply it by the original second, and then we're going to add the original first function and multiply it to the derivative of the second function. And then the quotient rule looks a lot more complicated. It is, but that doesn't mean we can't figure this out on our own here. And basically, the quotient rule basically says this. If I have to take the derivative of a rational function of any kind, all I have to do is take the derivative of the numerator times the derivative, or times the the denominator function, subtract the derivative of the denominator times the numerator function, and then divide all that by the square of the denominator function. Once again, we'll break through this together and we'll figure this out as we go along. So when we talk about the product rule, once again, I kind of went through this together. If we wanted to shorthand this, let me move this up a little bit here for you guys. So if we wanted to shorthand it, we could write it as two functions u and v, where we have the derivative of u times v plus u times the derivative of v. Okay. If we wanted to, basically, this is necessary for any composite function. We can call it j of x, as presented as the product of two smaller functions, f of x and g of x. This basically, the way I think about it is, if you have a quadratic function and you want to factor it, you can do that. Or if something's already factored, finding the derivative of a factored function is what we would use this for here. Okay, so one example is, let's say we wanted to find the derivative of 2x times 6x squared. Now, I know you're probably thinking, okay, we can multiply those together and get 12x to the third and then use the power rule. Yes, absolutely. But let's say we have this and we didn't know the power rule. The way we want to set it up is, we know that f of x is 2x and g of x is 6x squared. Or if you want to use the u and v rules, we could say u is equal to 2x and v is equal to 6x squared. Here we want to apply the power rule as best we can, or the sum and difference rule here. So the power rule applied to 2x just becomes 2. So the derivative of 2x is just 2. And the derivative of 6x squared can be modeled using 12x. I take 2 times 6, and then I subtract the power by 1. That gives me 12x. And then I just use this rule up here to fill in what I know. So f of x becomes 2x. The derivative of so if I'm finding the derivative of this product here, I take the derivative of 2x, multiply it by g of x. So I kind of do this look at it kind of across this way here. So 2 times 6x squared. And then I go from this corner here, f of x, I add 12x, which is the derivative, times 2x, which gives me these two products down here. So if I multiply these together, I get 12x squared plus 24x squared. I can combine both of those because they're like terms. That gives me 36x squared for the product of these two functions here. If we look at another example, a little bit more involved, let's say I have this product right here. Okay, find the derivative of 2x plus 1 times x squared minus 4. Okay, once again, we want to set it up the same way. We know our two functions, f of x is 2x plus 1, g of x is x squared minus 4. We want to apply the power rule to both of them. So the derivative of 2x is 2, derivative of 1 is 0. So once again, I'm just left with a constant value derivative for f of x. And then I'm left with g prime of x, or the derivative of g, which is just the derivative of x squared, which is 2x, and then derivative of 4 is 0, so I'm left with just 2x here. So if I want to find the derivative of this composite function here, I would do derivative of f of x, so 2 times g of x, so 2 times x squared minus 4, plus 2x, which is the derivative of g of x, times the original f of x function times 2x plus 1. And when I do that, when I distribute both of these terms to what's in parentheses, I get 2x squared minus 8, because I multiply by 2. And then I distribute 2x to 2x plus 1. That gives me 4x squared plus 2x. The only two like terms I have are 4x and 2x. Combine them, look like this. I'm left with 6x squared plus 2x minus 8. That's, once again, the derivative of the two products here. Okay, so something I want you to try to get on your own here. Okay, I'm not going to show you the work, but you can go ahead and try this. Try to find the derivative of 4x to the 5th times x minus 10. Okay, and if you do it correctly, you should end up with 24x to the 5th minus 200x to the 4th. Okay, so I'll let you try that on your own. Take a minute, pause the video, and see if you get the same thing I do. Moving on to the quotient rule here. Okay, so quotient rule, basically we're applying this huge formula right here to what we know about the power rule. And we're going to start off with something easy. So the derivative of a rational function, 2 divided by x plus 1. Okay, so once again, the numerator is our f of x, the denominator is our g of x. So f of x is equal to 2, g of x is equal to x plus 1. And we want to find the derivative of both of these. So derivative of a constant is always 0. Derivative of x plus 1 is just 1. And I go ahead and replace it all in this formula here. When I do that, I do, let's see, so f of x is 0. 0 times g of x is 0. These guys are going to cancel. And then 2 times 1 gives me just 2. And then I can leave this denominator, this g of x squared, I can leave it as x plus 1 squared. And then, let's see, so first term canceled out, 2 times 1 is just 2, so negative 2 divided by x plus 1 squared. Pretty simple, all right? But what if we have an even bigger example, like we do right here? Let's say we have the derivative of the function 6x squared minus 13x divided by 2x plus 5, okay? So with this one, we're still going to use this formula up here for the quotient rule, okay? When we do that, we replace f of x, we say the numerators are f of x, the denominators are g of x, and we find the derivatives. So 6x squared minus 13x becomes, when we take the derivative, is 12x minus 13. And then the derivative of this function here is going to give me 2. And then once again, I just replace derivatives with regular functions in the formula. So the derivative of this rational function becomes 12x minus 13 times 2x plus 5 minus 2 times 6x squared minus 13x, all divided by, once again, that g of x just stays squared. We don't have to simplify it right there. I use my FOIL. That gives me 24x squared plus 60x minus 26x minus 25. And then I got to make sure when I distribute the 2 here, it becomes, all my signs change. So this becomes negative 12x squared. And then I also make this a positive 26x. And then I combine my like terms. 26x's are going to cancel. And I'm left with, let's see, so 24 minus 12, that's 12x. 60x squared stays there, minus 65, all divided by 2x plus 5 squared. Okay? So, another you try it problem. I have it kind of set up for you here. Find the derivative of the rational function x plus 1 divided by x to the third. And I kind of give you a little bit of a setup here. Okay? I want you guys to send me your answers to this you try it as an exit slip here. Okay? Your homework for tonight is on Delta Math. You have an assignment called Product and Quotient Rule Practice. And then in the OpenStax textbook that I sent you guys this afternoon, you have these problems here. Page 263, numbers 106 to 117. Those are all the odd problems. And then numbers 127 to 132, all of those plus a challenge problem with number 147. Okay? If you have questions, make sure you come to class today with your questions, and I'll talk to you guys later. Have a great day.